Wondering how server components might help you in your React apps? In this short and very useful video, you'll learn in the first couple minutes what the motivation is behind React Server components. Then we'll expand on a partially built React app to fully create a dedicated landing page to display a list of conference speakers using server components. And finally, we'll compare the server component code with the equivalent SPA or React client component code. These short videos linked together are just several minutes of my 4-hour course at Pluralsight titled React Server Component Fundamentals in React. In that course, we start with introducing React Server components from the very basics and go all the way through complex apps that include hierarchies of both server and client components. The course is linked below in the comments. I hope you enjoy this short but useful video and it motivates you to head over to Pluralsight and sign up for a subscription so you can watch the full course. For us developers, there are things that are easier to do with React Server components. For example, anything to do with an asynchronous data source. The way server components work is at the top, we write an asynchronous function that we know is going to run inside a React server. Then in the component itself, we simply call that function. The beauty of that is in that function, we can do things like make direct connections to databases, again, because we know we're running on a server. If we're calling REST calls, we don't have to worry about cores or any of those other security issues. We just do server-to-server communication. Then in the component, when we get that data, we know that data is available. We don't have to worry about loading states because the React Concurrent Rendering engine took care of that for us. Basically, that makes our UI simpler. We don't have to worry about what happens when the data is there, when it's not there. We just know the data is always there. In the Pluralsight course, after about 3 hours and lots of learning about React Server components, we find ourselves having built out a list of conference sessions for our demo app. We've not yet built the list of conference speakers or the routing necessary to get there. For the next 5 minutes or so, you'll learn what it takes to create a React Server component that renders a speaker list. You'll also learn the necessary code to create a tabbed UI to get to that speakers list. It's basically Module 7, Clip 6. Let's watch that now. Having built out our first route/sessions, that is, we don't have much of a website. Actually, even when browsing to the root of our app, just localhost 3000 is going to give us a 404 page not found. We do have a plan though to create a tabbed interface that not only includes the base route, but also a dedicated speakers and landing page. Here is our current architecture. We just have a /sessions route, and below that, we have our page.tsx file and our optional loading and error components as defined by Next.js. Our plan is to change our component architecture to look more like this. We will have a new page.tsx file directly off of our root, and that will become a server component that renders at the base URL localhost 3000. We'll have a new folder /speakers along with the included page.tsx, which will be the component that renders on the route localhost 3000/speakers. Of course, the folder sessions stays the same with page.tsx rendering that route just like before. Notice also I'm showing a new client component, layout.tsx, at the top of our app. That file was there previously as it's required in Next.js and also auto-created, but now it's going to include all our navigation, which, as you'll see, the way we implemented it requires it to be a client component, so that is why it is orange. Let's head over to VS Code and make our app follow the architecture of this component diagram. As I mentioned earlier in the course, all Next.js apps that use the app router default conventions have a layout component, layout.tsx in our case, at the root app level. By default, it does almost nothing besides providing a body tag and optionally a place to put metadata, like for example, the header title and the header description. We're here in that file now. Since we want to add a top-level navigation to our app, that is tabs between a new home page, a new speakers page, and our existing sessions page, This layout.tsx file is the perfect place to add that, since its render children is always one of those 3 tabs. To start, let's add below our body tag a div that includes a semantic header. In that header's render children, put our not yet created new nav component, whose object will be to show a link to our home page, our speakers, and our sessions pages. While we're here, let's add a footer component that will always render at the bottom of all our pages. Import both components, nav and footer at the top, from the common folder as if they actually existed. Now, let's create that footer component in our common folder. Let's have it render just a simple string, Silicon Valley Code Camp, wrapped with the appropriate bootstrap and custom classes. Let's mark it as server only, just as a reminder that this component is going to run in the Node server, but that's not necessary, it's just good practice. Now for our more interesting nav component. Let's also create that in our common folder, and then have it return with all the expected bootstrap nav classes. A top menu that includes a nice image link to our CodeCamp logo that will display on the left, and then our 2 other tabs, Sessions and Speakers, both rendered with a Next.js link component. That is really all we need to render our page with our new nav control. Let's see. Refresh our browser, and we've got our nav bar on top as we'd hoped. Just don't click on the SVCC logo, which will be our homepage, or the speakers link, as both of these have not been created yet. Let's create that speakers route now. First thing, create the speakers folder under app, and then to make the folder routable, add the file page.tsx. For now, just create a simple server component that renders 3 dummy speaker lines. Coming up shortly, we'll make it real by getting our actual speakers, but for now, let's just stick to creating our navigation shell. For our homepage, we already have the route to the base URL of our site. That's just the source/app folder, but until we put a page.tsx in it, localhost 3000/ is not routable. So add that file. Scaffold another simple server rendered component that has a nice title, a description of our event, and a nicely formatted with Bootstrap description of it. That's it for our working navigation. Refreshing our browser, our sessions completely load, clicking on our SVCC logo, which is our link to localhost 3000/, and that displays our nice homepage. Notice also the footer at the bottom. Then clicking on the speakers link in the nav menu, that shows our 3 dummy speakers, as well as our footer again, and back to our sessions, which worked before, and here's our full async loading process with the placeholder images, then finally our sessions render. Nav is working as expected. Let's finish out building our speakers route. Previously, we just put up 3 dummy speaker lines with the intent we would replace them with a list of all speakers at our conference that included a bio and a picture. To do that, all we need to do is convert our /speakers/page.tsx synchronous server component into an async one and add the simple async function at the top of the component that retrieves our speakers list directly. We can do that because it's running directly in our Node server. Then, just like for sessions, we can add a loading and an error TSX file to handle the placeholder renderings as well as what happens when there's an error when the speakers get fetched. Let's switch over to VS Code and make the straightforward updates. The file we are looking at here is our dummy speaker rendering. We just left this as a template of sorts with the plan to fill it in with real code that fetches real speakers later and now is later. Before doing any coding though, let's navigate to our tsconfig.json file where we have our path aliases and add a new alias for speakers to make sure our imports don't get mixed up with problem relative paths. This helps us with not only components we're going to build here to support our new speaker tab, but also any other components that need access to these components that are in different folders. Let's go back to our speaker/page.tsx file. As written, it's a synchronous server component because it does not deal with any async data sources, but that's going to change when we retrieve our speaker's data. So make the component async. At the top, create an async function that will run in our node server called getSpeakers that simply awaits a call to delay for 2 seconds and then returns our JSON data that we've stored locally as an array. Remember, in a production app, getSpeakers will likely be using something like fetch to get data from a REST server or database, and by creating this delay, we are accurately simulating the same kind of async return you would get when reaching out for data. Now in our component, call await getSpeakers, and then replace our dummy array of 3 numbers with our return speakers. Since we have a TypeScript interface defined for speakers in our common folder, let's add that type to the mapping parameter speaker and import it at the top. Next, let's replace our key value with speaker.id, and for our render, replace what we have with a call to a new component we've not yet written called speaker detail with bio, passing our speaker value as an attribute. Then import it at the top as if it existed already. Now create it in our speakers folder. Remember, the only file that gets exposed from this folder is page.tsx. All other components or files can only be accessed through imports from exposed components. Creating this server component, which has no async functionality, is very straightforward. Let me scaffold it out for you. It just takes in as a receiving prop speaker and then formats and renders that particular speaker, including rendering a nicely styled image. Nothing fancy. Let's refresh our browser and see how we did. Well, it looks great, but we did have a 2-second delay with no placeholder being shown. That's an easy fix. Let's create a new component in the speakers router folder named loading.tsx, and for now, scaffold out a simple synchronous component that just renders loading ... We can do better than that though. The easiest way to improve our UI loading experience is to go to our original speaker render in our page.tsx file, copy that render code from there, and paste it into our loading.tsx files render section. Replace the speakers that we map over with a simple array of numbers. The length of that array is how many placeholder speakers you want to show, and then for each image, instead of rendering the component speaker detail with bio, just go to that component, copy the render section, that is the JSX, and bring it back and paste it into our map function. Make some simple changes like replacing the speaker image with a loading image and replacing the name with a different loading image. Now when we refresh our browser, just like our sessions page, we have a nice placeholder rendering while our speakers are retrieved, and finally the real speakers render. Having completed the basic speaker list in the course using a React Server component, let's jump to the final module in the course where we look at what the equivalent code would be if we did not have React Server components. That is, if we had to build the same functionality with local component state and the useEffect hook. It's basically Module 8 clip 4. Let's watch that now. What we're looking at here is the SPA code on the left in a light theme, and to differentiate it, the React Server component code on the right in dark mode. Skipping the imports for now and starting at the top, in both cases we have to get data from a remote source. Whether this code runs on the server or runs on the client, we can have the identical async function for doing that. We've got that here as just getSpeakers. On the left, our SPA app, we need to create a bunch of state to track whether the data is downloaded, whether there's an error, as well as the actual data itself. Then we need to code a useEffect hook to update all those state values as the data is downloaded through the component's life cycle. That is, when the component is first created, there's no data. After the component renders, we need to fetch the data. And then finally, when the data fetch completes, we need to display the data and make sure we concern ourselves with what happens while the data is downloading. Scrolling down in this SPA app, you can see the conditional code that makes that all happen. Moving to the right in our React Server component for displaying our speakers list. To get the data, just one call. We can assume that when this await returns, that we can immediately render the data. Then of course, in a React Server component, we just render it. No concern over state, no concern over errors, the component just renders. I'm not saying in an RSC we don't have to worry about loading states and error conditions, but because of React suspense and error boundaries, it's much easier to separate those concerns into other components without a lot of boilerplate type code like we have in our React client-only SPA component. I hope you've learned a little bit about React Server components and how they may benefit you while doing React development. The full course on Pluralsight is about 4 hours and hopefully will provide you a lot of value in learning all about how to use React Server components in your apps. You can get to the course by using this short link below or just go directly to pluralsight.com and search. This is the most recent as of now of my 5 courses in the Pluralsight React 18 path.